Alright, let's dive into the fascinating science behind rainbows. To fully understand how rainbows form, we need to discuss three key principles: reflection, refraction, and dispersion of light. These principles work together within water droplets in the atmosphere to create the beautiful, colorful arcs we see in the sky. First, let's talk about reflection. When sunlight enters a raindrop, it reflects off the inner surface of the droplet. This reflection causes the light to bounce back towards the direction it came from. Essentially, the raindrop acts like a tiny mirror for the sunlight. Next up is refraction. As light enters the water droplet, it slows down and bends due to the change in medium, from air to water. This bending of light is called refraction. When the light exits the droplet, it speeds up again and bends once more, changing its direction as it moves back into the air. Now, let's discuss dispersion. Sunlight is made up of various colors, which travel at slightly different speeds. When sunlight enters a raindrop, these colors separate from each other due to their varying speeds. This is known as dispersion. This separation of colors is what causes the different hues we see in a rainbow. So to sum it up, when sunlight interacts with raindrops in the atmosphere, reflection, refraction, and dispersion of light work together to create the beautiful phenomenon we know as a rainbow. Now that we've covered the science behind rainbows, let's focus on the role of sunlight in creating these colorful spectrums. Sunlight is essential in the formation of rainbows, as it is the primary light source that interacts with raindrops in the atmosphere. Sunlight, often referred to as white light, is actually composed of a range of colors. When this light interacts with raindrops, the different colors within sunlight start to separate, thanks to the processes of reflection, refraction, and dispersion that we discussed earlier. As sunlight enters a raindrop, it slows down and bends due to refraction. This bending causes the light to split into its various colors, which then disperse and reflect off the inner surface of the droplet. When the light exits the droplet, it bends once more and speeds up, continuing on its way through the atmosphere. The interaction between sunlight and raindrops is what allows us to see the colorful spectrum of a rainbow. Without sunlight, there would be no light source to refract, reflect, and disperse within the raindrops, and we wouldn't be able to witness this beautiful natural phenomenon. Let's take a closer look at how raindrops act as tiny prisms bending and reflecting sunlight to form the circular arc of a rainbow. When sunlight encounters a raindrop, the light undergoes reflection, refraction, and dispersion, as we discussed before. These processes are crucial in transforming the raindrop into a miniature prism that helps create the rainbow's arc. As sunlight enters the raindrop, it slows down and bends due to refraction. This bending causes the light to split into its various colors, similar to how a prism separates light into a spectrum. The colors then disperse and reflect off the inner surface of the droplet. When the light exits the droplet, it bends once more and speeds up, continuing on its way through the atmosphere. The circular arc of a rainbow is formed because each raindrop disperses and reflects the sunlight at a specific angle. This angle, known as the critical angle, varies for each color within the spectrum. When sunlight interacts with countless raindrops in the atmosphere, the different colors bend and overlap, creating the circular arc we see as a rainbow. So, in essence, raindrops act as tiny prisms that bend and reflect sunlight, ultimately forming the beautiful circular arc of a rainbow that we can observe in the sky. Now that we've covered the science behind rainbows and how raindrops act as tiny prisms, let's delve into the spectrum of colors in a rainbow and understand their order. You might be familiar with the acronym ROY GBVV, which represents the sequence of colors in a rainbow: red, orange, yellow, green, blue, indigo, and violet. The reason these colors appear in this specific order is due to their wavelengths and the way they refract and disperse within the raindrops. When sunlight enters a raindrop and bends, the colors with longer wavelengths, such as red, bend the least. On the other hand, colors with shorter wavelengths, like violet, bend the most. This difference in bending angles causes the colors to spread out and form the spectrum we see in a rainbow. As a result, red appears on the outer edge of the rainbow, while violet is found on the inner edge, with the other colors arranged in between according to their wavelengths. In summary, the spectrum of colors in a rainbow is arranged in a specific sequence, ROYGBIV, due to the differences in their wavelengths and the way they refract and disperse within raindrops. This beautiful array of colors is what makes rainbows such a captivating natural phenomenon. Lastly, let's explore the different types of rainbows, including primary, secondary, and supernumerary rainbows, as well as the atmospheric conditions that led to their formation. 1. Primary rainbows. These are the most common type of rainbow, and are formed when sunlight is refracted, reflected, and dispersed within raindrops once. The colors in the primary rainbow follow the familiar ROY-GB-5 sequence, with red appearing on the outer edge and violet on the inner edge. 2. Secondary rainbows. Sometimes you might notice a fainter, larger rainbow above the primary one. This is called a secondary rainbow and is formed when sunlight is reflected twice within the raindrops. In a secondary rainbow, the colors are reversed compared to a primary rainbow, with red appearing on the inner edge and violet on the outer edge. Secondary rainbows are less vibrant than primary rainbows because more light is lost during the double reflection. 3. Supernumerary rainbows. These are a series of faint, closely spaced, and slightly curved bands that appear on the inner edge of a primary rainbow. Supernumerary rainbows are formed due to interference, the interaction between light waves after they've been refracted within the raindrop. These rainbows are more commonly observed when the raindrops are small and uniform in size. The formation of these different types of rainbows depends on various atmospheric conditions, such as the size of the raindrops, the angle of sunlight, and the presence of moisture in the air. By understanding these factors and the science behind rainbows, we can better appreciate the captivating beauty of these natural phenomena.